Hey y'all, today in this episode we're going to be talking about systems of equations. So I want to give you the general description of what a system of equation would look like. So for systems of equations, you'll end up with two equations that would look similarly to this. Now A is going to equal a number, all the constants that we have there, A, B, C, D, all the alphabet letters except for X's and Y's. So those will be considered constants or will we consider just real numbers. Now x's and y's will will stay variables. All the rest of the letters will be considered constants. So what we'll see from here is that depending if they're word problems or if they're just problems that they give us, we'll have to set up the problem and go ahead and solve it with the methods that we will acquire. So the first method that we actually will go over is either substitution, or the second one will be elimination. Now, I always say it like this. You need to know both of them, but just picking one and working with it until you understand it completely, that's going to be the best way to go ahead and work through them. So substitution turns out to be we set up what are the two equations, either to y is equal to something or x is equal to something. Now, they're going to look very similar to like slope-intercept equations because we're moving variables around. So keep in mind that that's what it's going to look like, but make sure to not think it's just, put it right away into slope-intercept form or something like that. So that's usually what substitution turns into play. Now, depending on the question, you want to pick your method based off the question. But like I said before, just pick one method and stick with it until you feel more comfortable to move on. Now, elimination, that one may take a little bit more minutes. So depending on what I read right now off the example is a method that I'll go ahead and pick. So with elimination, what ends up happening is that you need to cancel off a specific variable. So cancel a variable is really the statement. However, there are certain guidelines and certain rules to it. So depending on which one, I'll go over that. I'll go over that specific method at that point. So this is a problem that I went ahead and solved from a student. So we'll take a look at it really quick, just so we can see an example and pick a method and kind of work with it best to our abilities. So they have here. So the admission fee at an amusement park is $3.50 per child and $14 for an adult. On a certain day, 315 people entered the park, and the admissions fee collected a total of $2,310. How many children and how many adults were there? So here, we know it's a system of equations. Because of the way the problem is worded, we're given two systems, and we're going to build the systems as we work through them. So the first system that I want to go ahead and show you is that we're going to work with a dollar amount equation. So pretty much put all the things in dollars in the same row. So what we'll see is 3.50, and I'm gonna call this C for children, plus 14.00A because that's for adults. Now they told us that the amount of money that the ticket person picked up essentially was $2,000. So $2,310.00. So as you can see, I grabbed all the values that had money in it or something in terms of money, and I worked with that. Now I'm gonna go ahead and what I call. So I usually call cash monetary value, and then I call the actual number of tickets sold. Usually that's what I'll say. It's either the monetary value or non-monetary. This one's going to be non-monetary, so what we're going to be looking at is how many did they specifically buy. Well, we don't know how much they bought, but we do know how much in total how much they did buy. So that's kind of what we're after now. So what we could say is that if I take the C for children plus A, we get to say that they bought 315 tickets. So that's the amount of people that went there. That's how we'll get there. Is that from when I add C tickets plus children tickets plus adult tickets will end up giving us 315 tickets sold. So now with this method, I think overall maybe substitution may be the best bet. So I'll work with substitution on this one. So what I'm going to do is I'm going to subtract C. So I'll end up with A is equal to negative C plus 315. So this is the equation we will be substituting back in. So that's what it will look like. So as we move down here, so we go ahead and start with our old equation, or the first equation, which is 315C plus 14A, which will equal to 2310. So that's a 2,310. So we already know on our second equation that a is equal to negative c plus 315. So what we're going to do is we're going to substitute the value. So the idea is whatever a is, we're going to replace it with it. So this is just going to go inside of here. So what we'll say is 350c plus 14. Now we get to say that this becomes parentheses. So that's what I like to say is that if we're working with variables, or substituting variables, substituting numbers, just think as a variable we're substituting as just giant parentheses. That's what they end up turning to be anyways. So what we'll say is that inside the parentheses, this blue box goes inside of. So then we get to say negative c plus 315. So then we'll just start distributing, clean it up, and we'll start working to see what our finished product would be. So we'll end up with 350c plus, and then this is what we'll start distributing the negative 14 inwards. Yeah, I don't want to put a bunch of arrows, if not, it's just going to get all crazy. So what we'll say is actually this will become negative 14c, and then we'll say what's 315 times 14. So 315 times 14 is 4 plus 4, 410, which is equal to 2310. Now what we'll do is solve for variable specific. So what I'm going to do is first take care of put our c's together. 3.50 plus, minus 14 gives me negative 10.5c plus 4410, which is equal to 2310. So then from here, what we'll see is that we want to subtract 4410, subtract 4410, and then we'll end up with negative 10.5c is equal to negative 2100, which turns out negative 2100. We'll go ahead and divide by negative 10.5, negative 10.5. So we'll know that our final product will come out to be positive. So we see that c is equal to 200. So that means that c is equal to 200. That means that there was essentially 200 tickets sold for children. So now what we can do is we can substitute either back into the original equations, kind of work with what we already worked with, so that's at your discretion, but I'm just going to stick with number 2 here. So I'm going to say a is equal to negative c plus 315. Like I said, we're substituting back in, so my bubbles will become here, and I'm going to leave this as a negative outside. So I'm going to say 200 plus 315, a is equal to. So negative 200 plus 315 gives us approximately, or essentially actually 115. So then we know that for our adult tickets, and remember this just FYI before I finish up the video, we always write these as coordinate points. So just be careful with it because these are solutions to our problems, to equations or linear equations. So just keep that in mind. So there's going to be more videos like this. Just go ahead and check them out if you need any assistance with systems of linear equations. Thanks a lot.